Hello and welcome. In this video, we are going to revisit our software design process. And specifically, we're going to start talking a little more about the top-down design. And we are finishing up, or rather continuing to work on some of the functions associated with our problem O2. Our problem O2 represents the flaky customer that has come back to you with some additional requirements, and you have decided that rather than get burned again, you're going to break the problem up from being one function into multiple functions. Now, this video assumes that you watched the earlier video that set up our problem O2 and the discussion behind it, and at least have gotten to the point where you are declaring and initializing the variables, collecting the information that needs to be collected from the user, and then displaying it from the command line. And so to give you an idea of what you should see or where you should be at is you should have your application running to this level. Now, what we want to do is we want to go look at our little helper functions. We have a few of them. We're going to talk about a little bit about a couple of topics here. First and foremost is I've given you part of the comment block. We want to finish out the comment block, at least for one of these, so you can see the pattern, and I'm going to leave the rest of them for you to do. But what we want to do is we want to add a description and a list of arguments to each of these functions. We'll start with our get box volume so you can sort of understand what it's supposed to do, and that it's supposed to calculate the volume of a box given the length, width, and height. Now, I realize that that was probably a very well-named function. It probably already lent itself to knowing what it does. In some cases, that's not going to be the case. Instead, what you want to do is just get into the habit of at least putting some basic description, as well as a description of the arguments. In this case, the length, which is going to be the length of a box, the width, which is the width of the box, the height, which is going to be the height of the box, and then also you want to include the return value, which is it returns the volume of the box. Again, pretty straightforward for this particular example, though even within this simple project or problem, there can be some ambiguity with some of the other functions. So the other thing I want to point out is we're doing absolutely no error checking, absolutely no validation. In other words, technically speaking, somebody could pass a negative length, a negative width, and a negative height, or any combination of those. We would, in the future, need to validate those values. In other words, need to make sure that they're all greater than 0, or there would be some problems. But for right now, what we're going to do is we're simply going to make our calculations and return the appropriate value. In this case, what we want to do is create a local temporary variable that is going to be of the same type as the return type. So in this case, it's going to be a double. I know that because on the left side of the function, I have double that specifies the data type for the return value. I want to then appropriately name my variable, and the logical one to me is going to be a box volume. And just like in our other examples, we want to go ahead and get into the habit of initializing these, although we're not going to have any real logic in this, so it's going to probably be pretty straightforward in what we would want to do, in that we want to just simply calculate the value. So you could technically skip this step for this very simple function, and that our box volume is just going to be our length times our width times our height. Now, at this point, then we are ready to return the box volume. That is going to be the value then that is going to be returned to whatever function happens to call our get box volume. A couple things to point out is, number one, there is absolutely no validation in here. In other words, it is quite possible that somebody could have passed negative values. is this step technically extra where we initialize it to 0? However, though, if you did any validation in here, you may end up in a scenario where you would be utilizing the box volume and it would be uninitialized. So again, it's probably a really good idea to keep initializing these values, even though they technically cost an extra step in the processing of your application. So good idea to initialize. There's many more times where that will help than what it will hurt. The same is going to be done then for the get the cylinder volume function. And then what we're going to do is we're going to have double. And then again, I'm going to just simply call this one cylinder volume. I'm also going to go ahead and initialize it equal to 0. And this is probably one of those great examples of where there's a little bit of ambiguity in there. In other words, what is the height? Well, this will happen to have our little widget or a little object here to recognize that the height is essentially the height of this cylinder. The radius, of course, is the radius of the cylinder. We're not dealing with slant heights or anything like that for this particular one. So what we're going to do then is we're going to just simply calculate the cylinder volume is going to be equal to the area of the hole times the height. You got a couple of options about how you would go about doing this. If you decided to use the pi radius squared approach, then what you'd want to do is you'd want to remember to include your math.h. So it's going to be pi times the radius times the radius, or what you can do is you can use the pow function. I like to nest the parentheses just to be clear on what's going on, and then times the height. So effectively at this point, what you have is you have pi r squared h. And then lastly, you want to remember to return the cylinder volume. Now, before we go any further, because we have used the pow function and we have our value for pi, we want to make sure that we have included our math.h. All right, so back to our little helper functions again. Our get difference. Our get difference is probably a little bit of an overkill function. In other words, it's going to be probably the simplest of all of them. I'm just going to go ahead and call my variable difference volume. Probably not the best variable name in the world, but it gets you the idea of what's going on. We're initialized to 0. Again, probably not something that we would have to do because we have no logic. But again, within any of these functions, we have no logic. So the path through the function is pretty clear. You ultimately would want to check, for instance, to make sure that the cylinder volume is in fact not greater than the box volume. There's actually several things that you'd want to check before, not the least of which is that the radius is less than, or rather 2 times the radius is less than the length and the width of your object, depending on the orientation. But again, we're keeping this simple. So the difference volume is going to be equal to the box volume minus the cylinder volume. And then again, what we want to do is we simply want to go ahead and return our difference volume. And then lastly, probably the trickiest function of all that we have to deal with, it's actually got a couple of things that we've got to address, is the calculation of the quantity. And notice right off the bat that our return value is now an integer, so we have to make our return variable also an integer, in this case int quantity. And we're going to figure out there's actually a number of different ways that we can go about doing this. But what we want to do now is we want to leverage the bulk volume and the object volume. So what we're going to do is we're going to divide the object volume into the bulk volume. And then remember, the efficiency is a value from 0 to 1. So we're going to multiply the efficiency against whatever we get from the result of the bulk volume divided by the object volume. So to start off with, I'm going to write this one wrong. I'll go ahead and initialize our quantity equal to 0, and you'll see why it's going to be wrong in just a second, and we'll fix it. But we're going to say quantity is going to be equal to our bulk volume divided by our object volume. Again, that simply gets us how many of them we would get if we were in a perfect situation, 100% efficiency, but we're not. So we're going to multiply it by our efficiency. Now, I said I was going to do it wrong to start with, and the reason I'm doing it wrong, or what I am doing wrong, is that you'll note that I'm taking a double, in other words, our bulk volume, another double, our object volume, dividing a double by a double, which is going to give us a double, and I'm multiplying it by another double. So a double times a double is also a double, which we talked about in an earlier video, and we are assigning it to a quantity, which is an integer. So we've got a couple of options about how we can go about doing this. One of which is we can use our floor function, but you'll notice the floor function has an interesting result in that it'll simply take a double and return a double. So even if we were to go about using the floor function, we would still have to do our conversion. But what we can do is we can just simply take and do a cast on the result of this calculation. And I'm going to go ahead and add one more set of parentheses here just so there's no confusion about what we're casting here. And so what we're going to do is we're going to cast the result of that division and multiplication from a double to an integer, and then assign it to our quantity variable, and then ultimately return our quantity. Now, at this point, we've got all of our little helper functions written. The only thing I ask that you do is go back and fill out the description and the arguments based on what we talked about in this video for each one of our functions so that our documentation is complete. And before we go any further, let's go ahead and build it. Sure enough, looks like we've got good code here. We have return values on all of these. Everything's looking promising. Now let's just go through the steps of actually utilizing these functions. So to calculate the volume of the box, we simply take the box volume variable that we created in our earlier video, and we set it equal to the return value. I apologize, I have absolutely no idea what hotkey I just clicked on. There we go. Sorry about that. So we have our get box volume. We pass to it a length, a width, and a height. Calculate the volume of the cylinder. We do something very similar. We say cylinder volume is equal to get cylinder volume. We passed it a height and a radius. To calculate the difference, again, we have a variable. Perhaps we forgot to create it. I believe we called it unit volume. Yes, very good. A unit volume is going to be equal to get difference. And the get difference is going to accept the box volume as one input argument, and the cylinder volume as the second input argument. Again, you want to be careful. The order does matter. Remember that we're doing no error checking here. So technically speaking, we could send all sorts of ridiculous values to these functions and they would technically work as long as there were no runtime errors. For instance, if you try here in this function to pass a 0 value for the unit volume, then you will end up with a runtime error. But the last step now is to calculate the quantity. So we'll say quantity is going to be equal to get quantity past the bulk volume, the unit volume, and the efficiency. And now hopefully in this simple multi-video demonstration, you can get a pretty good idea of why our top-down design is so important. Now, in another video, I'm actually going to graphically show you how our application works. But for right now, let's make sure that we've actually got something that does work, and we'll go ahead and build it. I'm going to go ahead and run it one more time. So for our length is going to be 1, our width is going to be 1, our height is going to be 1, for radius 0.125, and then for the bulk volume, I'm just going to do 10. and our efficiency at 90%. And you can see here that I have a box volume of 1, which is what I expected. We remember that from our earlier video. My cylinder volume is there based on pi r squared h. Our unit volume is 0.95, and because my efficiency is 90% or 0.9, I get 9 units out of my 10 cubic inch bulk material. So again, you could play around with these numbers. You could play around with your alignment a little bit. We accidentally ended up with a pretty nice looking table for the first pass. So I don't really have any changes that I need to make. But again, this is one of the advantages of going ahead and creating the output before you actually do your calculations. Could we have done the calculations first and then built the output? Yes. Might not have been quite as satisfying or as easy to test at the end, because then we would still be having to build the table. That doesn't really matter so much. So in another video, I'm actually going to show you then how the big components of our problem here, our project, fit together with respect to top-down design. But as always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.